Hello viewers, we're looking at partial variation today, and one of the simplest topic. Don't look at the way it is on the board. It's quite simple. I'm going to explain it in a very simple term. Now, if you talk about partial variation, we need two constants, two unknowns. Now, that is why I brought this question. So we're going to use this question to explain it to your own understanding. Now, the question is, the quantity y is partially constant. Now, when you say partially constant and partially varies inversely as the square of x. Question A now. Write down the relationship between x and y. B. When x is 1, y is 11. And when x is 2, y is 5. Find the value of y when x is equal to 4. Now, if anytime you see such a question, know that they're asking you question on partial variation, and it has a very simple approach. Now, see our solution here. Look at the question. The question says the quantity y is partially constant. That is why vary partially as constant. The first statement that y varies directly as a constant, and anytime, and this and now we introduce the sign of the addition sign, and partly varies inversely at the square of x. So, and before you mention, since the partial variation another constant, then inversely at this. So you can see that y is actually varying inversely as x. But the main thing, because it's partial, we have constant k and constant a. You must introduce two constants. Now, so you see that y vary partially as a constant and partially inversely vary inversely as x. So this statement is what the whole that place means in partial variation. Now look at what I did. Y varies as k. When I remove this a times 1 will give you a all over s squared. Sorry, we need to put a square here. Then you see here that y varies as k, so this now is coming out fine. By the time we remove sign of equality, just like any other type of variation, we now see that y is equal to k plus a over s squared. So this is equation 1. Now this is the relationship. In any exam you go to write, when they say what the relationship between x and y in partial variation, this answer that question. Good. Now we now come to a. There to b, when x is 1, y is 11. Look at it. When x is 1, y is 11. What we are going to do is to substitute this value in equation 1. That was what we did here. You can see that y is 11. Look at it. Y here is 11. K is constant. A is unknown. Then our x is 1. That is why we have 1 squared. And 1 squared is equal to 1. So 11 equal to constant k plus a over that 1. This one, by the time you use it to find the LCM of a and k, you are going to have this type of equation here. So this 1 times k will give you k. 1 times 11 will give you 11. That is why we arrive at it. 11 is equal to k plus a. Call this one equation 2. Now we can now come to here. Under the second case now, when x is 2, you'll be following it step by step. When x is 2, y is 5. Look at it. X is 2, y is 5. But y is equal to k plus a over s squared. Now look at our y. Y is 5. We brought it here. K is here. Then plus a. Then our x is 2. So we're trying to find the value of k in this place. So you see here that by the end of the day, in all partial variation, you must form simultaneous equation. Look at it here now. This is our y, 5, then k constant, a is also constant. By the time you find the LCM of, make this k over 1, for your understanding, that's why we arrive at making it a single equation. We find the LCM of, make this k over 1, then a over 4. LCM of 1 and 4 is 4. 1 divided by 4 is 4. 4 times k will give you k, 4k here. Very simple. Plus 4 divided by 4 is 1. 1 times a will give you a. Good. So by the time you cross multiply, 4 times 5 is 20. 4k plus a. Call that one equation 3. You can see that it has come to simultaneous equation form. Then we have already formed here in our equation 2. You can see here that equation 2 is here, equation 3 is here. We have brought them, the two of them as simultaneous equation. In all partial variation, you must arrive at this point to solve your two constants. Now, but then in solving simultaneous equation, we have two methods. We have elimination method and substitution method. For time, I'm just looking at elimination method. Under elimination method, you now see equation 3 minus equation 2. What does it mean? A minus A is 0. 4k minus k will give you 3k. 20 minus 11 will give you 9. So by the time you divide both sides, you are going to see that your k is 3. I believe it's simple. Now, you will continue from equation 2. You can see our equation 2 here. We want to know, substitute for the value of A. We have gotten our k as 3. Now, from equation 2, A plus k equal to 11. And already we have gotten our k as 3. So, A plus 3 equal to 11. By the time 3 goes this way, we become minus. So, 11 minus 3 will give you 8. So here on this page, we're able to get our value of k. K is 3 and A is what? So we have got our two constants. Now the last question says, find the value of y when x is 4. Simple. You have gotten your A, you have gotten your k. Look at that. So y is unknown, x is 4. But from equation 1, that is our beginning. Look at it here. Question 1 here, which is y equal to k plus a over s squared. Then you now look at that. By the time you substitute, so y is equal to k plus a over s squared. Our y is unknown, our x is, our k is 3, our a is 8. That is from here. Then the new value now, our x is 4 squared. So you now have 3 plus 8 over 16 squared. 16, 4 square will give you 16. So by the time we make it a single equation, find the LCM of 1 and 16. So that is 16. 1 divided by 16 is 16. 16 times 3 will give you 48. Good. Plus 16 divided by 16, 1. 1 times 8 will give you a simple fraction. So you now see that y is equal to 56 over 16. 2 here, 28 over 8. 2 again, 14 over 7. 2 again, 7 over 2. So 7 over 2 will now give you 3.5. So our y here now is equal to 3.5. So, all right, so we have solved the other one. You have seen how we solve it. Now look at the question here. The quantity Q is partly constant and partly varies inversely at the square of P. A, write down the relationship between Q and P. Question 2, B, when Q is 4, P is 12. And when Q is 8, P is 20. Find the value of P when Q is 12. So try this and leave your answer in the comment section. Thank you. Tune in for more exposition on mathematics.